Hello, it's me. I'm back again. Some of you are probably sick of the sight of me by now. If not, I'm lovely to see you all. I currently have 28 people it suggests are here, so some people must be enjoying it and must be learning something. If you are here on purpose, then you are here to learn about the mean and why we're being so mean and what we're talking about. So why are we being so mean? What are we going to be looking at today? We are going to be looking at a type of average called the mean. The mean is possibly the most powerful, but we are going to learn today that there are some things that are sometimes wrong with it. We are going to learn various different things about the mean. We're going to learn how to do the mean from a list of numbers. So those year 7s and 8s and any year 6s and 5s who have joined us will be able to learn to do that. We're going to look at how we can use frequency tables and graphs to be able to work out more complicated means, and hopefully I can make sense of that to you. We're also going to talk about why, what the point of doing it is, because so many times I try and teach lessons and people say, why are we doing this? When are we ever going to need this in life? And I'm going to do my best to try and make sense of it all to you. So, first off, the mean, when we first learn it, is an average, and it is used for allowing us to represent what the centre ground of the data is, what the general picture of the data is. Because in most situations, people will have collected lots of different bits of data. And we do talk about mode and median and other things, but we're focusing today on the mean. Now, in just a list of numbers, the first thing we normally do is we go, okay, we've got our list of numbers, we are going to go and add all the numbers together, divide by how many numbers there are. Add all the numbers together, seems fair enough, doesn't it? Add all the numbers together, divide by how many numbers there are. Add all the numbers together, divide by how many numbers there are. So, if I add all the numbers together, and there's 5 of them, I'm going to divide by 5. That'll give me a picture of the data. So, there's 4 for you to do now. You can pause the screen, I need to be out your way, and you can pause the screen if you wish to, or you can just have a go at them now. I'm going to be talking in the background while you have a quick go at these 4. So remember, to find the mean, you add all the numbers together first, then you divide by how many numbers there are. Good morning, Leo. Good morning, Paul. Good morning, Ben. Good morning, Luke. Good morning, Arlene Shelley. Good morning, Willow. So, hopefully you're already down to at least the second one. Good morning, Mr. Winterbottom. Nice to see you. We are going to be just finishing off C and D, hopefully now. And then I'm going to talk about what the answers are. So, to add them all together, divide by how many numbers there are. Few more seconds. It's not the best video ever, just watching other people doing sums, but hopefully you're all having a go at them. So 2 and 3 and 3 and 5 and 7 makes 20. So I'm thinking that's going to be 20 divided by 5. They all work like that. And all except for C are divided by 5. So I've tried to make them straightforwards. Hopefully we have therefore got, good morning, Sir Stings. We should have 4, 10, 8 and 4.2. It's okay for not being a whole number. It's absolutely fine to sometimes have a decimal answer instead, because it added up to 21, and 21 divided by 5 gives us 4.2. But that is the mean from a list of numbers. I mean, I'm not going to stop the video there after 6 minutes and say, well, the mean from a list of numbers, you add all the numbers together, divide by how many numbers there are. It's a lovely rhyme and a lovely rhythm to it, and I could just chant it at you, but you haven't come to me just to hear me chant, add all the numbers together, divide by how many numbers there are. First of all, what does it tell us? Well, in that group of 2, 3, 3, 5, 7, it tells us the mean bit, the middle, like all of the numbers are around 4. If we then had compared the group A to group D, we would say overall, although it might be surprising, overall the results for D are slightly higher than the results for A. Because the average, the mean average is 4.2, comparing it to the mean average of 4, 4.2 is slightly higher. So it's the general picture. But how does this apply when we come to something different. What about when we're dealing with frequency graphs and frequency tables? How can we apply the mean to a frequency table using the same stuff I've just taught you? What can I do that's different to make it so that it's very clear for us to understand? Well, that's why we're coming here. I am hoping you will join me. Here we have an information Majid has collected about some school dinners. And he has collected all the data into a frequency table. If you're not sure about this, do check out the primary school video from earlier and how he made the frequency table. But some people will already be clear on frequency tables and how he's made them. Now, when I see people trying to find the mean here, the most common mistake I see is they remember what I've taught them, add all the numbers together, so they go, oh, 8, add 12, add 6, add 4, add 2. And then we divide it by 5, and that's the mean. No, we do not do that, because the 8 isn't a number of school dinners. This is our data. This is the most important bit in this section, not these numbers. These tell us how many. If we were to write this out in a list, there's 0 zeros. However, there are 8 ones. 1, 1, 1, 1, 1, 1, 1, 1. The easiest way to work out 8 ones is 1 times 8, which gives us the total of 8. So in total there are 8 if we add all those ones together. Remember, we're adding all the numbers together, divide by how many numbers there are. So let's add all the numbers together. There are 8 ones. There are 12 twos. This is going to take me a while to write. I'm up to 6, I think. Hope I don't lose track. So I think that's 2 12s. But a quicker way, rather than writing them all out, would just be to say 2 times 12 is 24. If I add all the 2's together, I get 24. In fact, if we call this column data times frequency, we can actually multiply these together. There'll be 8 ones, 12 twos, 6 threes, 4 fours, and 2 fives, giving us 18 and 16 and 10. We have got 8 ones, 12 twos, 6 threes, 4 fours, and 2 fives. So that is our total of our data. Remember, the 2 fives just look like that. This is not a 2. There are no 2's here. There's 2's here. There are no 12's, but there are 12 twos. So we now want an extra column called row called total. I don't know how well that's going to show up. Total. I think there are 20, 30, 32, and in this total, if we add them all together, we've got 26, 36, 44, 48, 68, 76. Let's just check that again. 26, 36, 44, 48, 68, 76. And the mean, if we remember, is add all the numbers together, divide by how many numbers there are. Well, this here is adding all the numbers together. And this here is how many numbers there are. The frequency tells us how many. That's what frequency means. So therefore, that's a terrible arrow. Therefore, there are 32 people, students. 32 students, and they ate their dinners over the course of a week, and so this is the number of dinners that were had. Okay, so therefore we've got 76 divided by just checking you can see that, probably not, mean equals 76 divided by 32. Now you may have noticed there's a couple of questions I've ignored here. The mode, because we're not really focused on the mode, but I will briefly mention it. The mode is the most common. Therefore, there were 12 students who had 2. So I think the mode is 2. 32 students altogether. School dinners altogether was 76. And that's how we work out the mean. And I might need a calculator for that. I think it's going to be about 2.4. But I've placed my calculator somewhere safe to make sure that I'm able to work this out for you. 76 divided by 32 is a 2.375. But what does this mean? This means, on average, students had about 2.4 school dinners a week. On 2 days, and then each 2 weeks they maybe had one, except for the odd week where they didn't. But this is the average number of school dinners per week. Two students had school dinner every day. 8 students only had school dinner on one day. But using this table is how we go about it. What this means is, I'm going to try not to use the word mean, because it's all about mean. What this should mean is, if we scroll down to our next question, if you pause the video now, sorry, I froze rather than pausing the video. If you pause the video now, you can actually have a go at this question yourself before I do. But you don't have to. I'm going to go through it myself. But this is a second chance to see exactly what we're talking about with finding the mean from this frequency table. Remember, 9 is not in this table, which is confusing. But it's not there. There are 9 ones in this table. So, I've now given you a chance to pause it. We're going to switch. What colour do I fancy for this? I reckon a nice purple. And I am going to do data times frequency. 0 times 5 is actually 0. Don't make the mistake of putting 5. 1 times 9 is 9. 2 times 7 is 14. 3 times 4, I need my multiplying. 3 times 4 is 12. 4 times 3 is 12. 5 times 2 is 10. Now, I've rushed through that. Remember, the reason I'm timesing them is because there are 3. This is how many? There are 3 4s. If I was to write them all out, they'd look like that. 4 add 4 add 4. There are 2 5s. I could write out all the data, but there's no need. So when it says what's the mode, there were 9 1s. So I think the mode is 1. Remember, the data is what we're interested in. How many adults were asked altogether? Josh asked some adults how many cups of coffee. So how many adults were asked altogether? 2, 5, 9, 18, 25, 30 adults were asked. How many cups of coffee? We need to add up this column. 2, 4, 8, 17. 1, 2, 3, 4, 5. 57 cups of coffee. Now, that's not as much cups of coffee as I often drink. So that's probably a standard day for me, 57 cups of coffee. Certainly while I'm trying to keep myself doing live streaming every day. So, we have 57. And then the mean is equal to 57 divide by 33. Add all the numbers together, divide by how many numbers there are. So we've got, I'm going to predict that's about 1.9. Let's see. 1.82, what am I, 1.92? 2.84, I've divided by 20. Silly Mr. Harris. 1.9, smashed it. Okay. We've now got the mean. What does that tell us? It tells us that on average, the adults were drinking just less than 2 cups of coffee a day yesterday. Yesterday, with lots of people at home, stuck at home, maybe the tea and coffee rates are going up. I don't know what's happening to the tea and coffee. I'm going to have to investigate it. I'm going to have to ask everyone in the UK how much tea and coffee they had yesterday and find the mean. It might take me some time. So if you can just sit there... No, I probably won't do that now. I'll maybe do that tomorrow. So before I carry on, I just wanted to tell you, I always believe in trying to introduce information to you. And there's some information that some of you might not know. Did you know, for example, I found out yesterday the difference between a teaspoon and a tablespoon. Apparently, a teaspoon you use to stir tea and a tablespoon you use to stir tables. You learn something new every day. Anyway, let's move on. We've done frequency tables, but look what we can do if we scroll down further. We now have a bar chart. In this bar chart, it says some students were asked, I don't know whether that's going to be hidden behind me, so I'm just going to check slightly. So, there we go. Some students were asked how many pets they owned. The results are given in the bar chart below. So, how many pets they owned? We haven't got the frequency table, and we need the frequency table to be able to do the mean. But don't worry, because one of the things we can do, you don't have to make that noise, is that is 6, because that's how high it is, and that is 15, and that is 12, and that is 4, and that is 2, and that is 1. So we can put in 6 there, 15, 12, 4, 2, and 1. You can turn your bar chart into a frequency table. And then if we write total, we've now got the completed table. We can write down the mode. Remember, the mode is the most common. It's the highest bar as well. So we can write, if my sideways writing is any good, that's the mode. So the mode is 1. How many students did I ask? Well, we have to add this total together. 21, 23, 33, 37, 39, 40 students. How many pets are owned? Remember, this is not the pets, this is the students. 15 people have 1 pet. I'm not going to write 1 15 times, but that means we can do our timesing method. You don't have to sing the song. 0, 15, 24, 12, 8, and 5. Add them all together, you get 39, 41, 51, 59, 64. I always like to check. 5, 20, 44, 46, 56, 64. So we now have to find the mean. We've got the 64. We've got the 40. The mean is add all the numbers together. So add all the pets together. Divide by how many numbers there are. Divide by how many students there are. 64 divided by 40 is 1.6. That means on average there are 1.6 pets per student. Each student's got 1.6 pets. Now, it is actually illegal to keep 0.6 of a pet. Try and keep whole numbers of pets if you can, please. Okay, let's move back to my PowerPoint. Where have we got up to? Hopefully, we've got an idea now of how we can find the mean from numbers, add all the numbers together, divide by how many numbers there are. From frequency tables, we use that special method of multiplying the tables together and adding down the side. Remember, there is in the description a link to some worksheets to practice these skills. And then we've got one on bar charts as well, and how we can use bar charts. So what problems are there with the mean? There are 2 that I can think of. One, politicians use this all the time, and it does my head in. And I find myself shouting at the television, going, "Hurrah!" And my wife has to say to me, it's just the TV. I'm like, but they don't understand the mean. The first problem I have with the mean is people say, oh, according to the statistics, half of the people are underperforming. They're scoring less than the average. But that's how mean works. If we try to get everyone to get the mean, then the mean moves. If everyone improves, the mean goes up. Not everyone can be above average. That's impossible. So it's very important to remember, if you're grading everyone, you can't always be above the mean, even though you're working hard. But you can try to be and aspire to be. It annoys me when they say people like, oh, half the people were below average. Of course they were. That's how mean works. But there is one more problem that you can have with the mean, and that is one random bit of data. So I'd like you to imagine for a second that you have travelled the following distances last week. So I was able to pop out to walk the dog last week for my 1 day of exercise that we're allowed. I would like you to imagine on Monday I did 100 metres. On Tuesday, 100 metres. Wednesday, 100 metres. Thursday, 100 metres. And then on Friday, I went for a run of 10,000 metres. Then I look at the average. You all heard me say 100 metres 4 times. So realistically, on average, I was going 100 metres every day. Except with this method of doing the mean, add all the numbers together, divide by how many numbers are. We've got 100 plus 100 plus 100 plus 100 plus 10,000 for my 10 kilometres. Divide it by 5 and it says I was going 2.08 kilometres per day. That's one of the small drawbacks. If you've got small amounts of data and one huge number, it can mess up the data. That's why in science you're taught about removing data that's weird, data that's out of the place where it should be, and trying to make sure that's erroneous data. We want to get rid of that. Don't want to include that. If it's really extreme, we normally try and avoid using it. So, what have we learned today? Well, hopefully we've covered all the different things about finding the mean, what the mean is, how to work it out from a frequency table and a graph, and some problems with it. Therefore, moving on. I have set you 2 challenges. Now, unfortunately, one tiny error. It shouldn't say Taskmaster Challenge at the top. It should say Worksheet Challenge. The Worksheet Challenge is to complete the mean worksheet. The link is in the description below, and I will try and put, I believe the answers are up now, or I'll try and put them up at the end of the day. So you'll be able to mark the answers as well. Then, feel free to ask any questions in the comments below the video. I probably need to get rid of this so you can actually see what I'm talking about. What you need to then do is either post questions in the comments. Luke, please stop spamming. 2 seconds, everyone. It's obviously very difficult. Right. What you need to do is complete the worksheet, and then you can go to the Facebook group to comment. You can show various different things. I'll show you some links in a second of where you can ask questions, where you can get information from me, and how you can get help, but also just show me the work you've done, because it's always good to get some feedback on what you've done. But I've also got you a challenge. I want to challenge you to make the best, smallest picture. So all you have to do to submit that picture is, again, in a second, I'm going to show you this. This is me. These are the ways you can contact me, and there's also an email address that I keep meaning to add to it, which is schoolofmrharris@gmail.com. And if you want to contact any of those, then you can also get in touch with me, and I'll see your entry to your best, smallest picture. I'd love to be able to put that on the slide for tomorrow, for Wednesday's lesson, and see, obviously, how people get on making the best, smallest picture. And there'll be a new Taskmaster Challenge, that lesson after that. So that concludes our lesson on the mean. I hope I wasn't too mean. I hope you all understood what I was talking about. If you do have any questions, I'll be in the chat. Please ask how to do things. And I am out. Speak to you tomorrow.